Hey everybody, in AP Computer Science Principles, welcome to the second part of Unit 8, Lesson 1. Today we are going to be scoring some samples of the Create Performance task using the College Board rubric. So we're going to go over the rubric. I'm going to show you one sample and how it was scored. We'll go through it together. And then I'm going to ask you to score two others on your own. And then finally, I'll go over the correct answers to the final two projects that you're going to be scoring. So as a reminder, first of all, at the end of our create performance task, there are three things that you're going to be submitting. A video showing your program's main functionality, including input and output, a PDF of your program code, and a PDF of written responses. Now, I actually think that is technically false. You're going to be putting your responses directly onto the AP Digital Portfolio website, but we don't need to worry too much about that right now. We'll get to that when we need to. What I want to look at specifically today is the written responses and the video. That's what we're going to be focusing on when we score sample projects. So just to remind you, from yesterday, we looked at written responses, and there are all of these boxes that you're going to have to fill in for 3A, 3B, 3C, and 3D. And I kind of read through each of those, so I'm not going to do that again, but feel free to kind of reference this part of this file while we go through the rubric, which is what we are going to do next. So the create performance task overall accounts for 30% of your AP exam score, but that whole 30% comes from only 6 points on the rubric. You can get up to a 6 out of 6 for this project. So every single one of these points is extremely important. It is a big part of your AP exam score. So we want to be very, very focused on getting these 6 points. And as long as we get these 6 points, we don't really have to do much else for our project as long as these six things happen. So the way that this rubric works, it's split into what are called rows, and each row is worth 1 point. So we're going to examine row 1, row 2, row 3, row 4, row 5, and row 6. So that's what we're going to talk about here. And each one of the rows corresponds to a certain part of either the video or the written responses. And that's kind of what's explained over here. So row 1, we'll just get into it. So row 1 is focused on the program purpose and function. And the scorer, who uses the rubric completely, row 1 is going to consider only the video and written response 3A. So remember, written response 3A wanted to know the overall purpose of the program, the functionality of the program that's demonstrated in the video, and the input and the output that are demonstrated in the video. And here's the scoring criteria. The video demonstrates the running of the program, including input, program functionality, and output. So those must be true. And the written response describes the overall purpose of the program, describes what functionality of the program is demonstrated in the video, and describes the input and output of the program demonstrated in the video. All of these things must be true in order for you to receive this 1 point. Do not award a point if the following is true. The video does not show a demonstration of the program running. Screenshots or storyboards are not acceptable and would not be credited. You must actually show the video running in the, you must show the program running in the video. Row 2, data abstraction, worth up to 1 point. The written response includes 2 program code segments, one that shows how data has been stored in the list, and one that shows the data in this same list being used as part of fulfilling the program's purpose. The written response identifies the name of the variable representing the list being used in this response and describes what the data contained in this list is representing in the program. All of this must be coming from only written response 3B. And notice that row 2 and row 3 are coming from written response 3B. So that's it. Row 4 moves on to a different part. So there's up to 2 points coming from written response 3B. Just to remind you, this is what 3B looks like. So we need to have data being stored in a list. That list needs to be used. And then this is the written response. We identify the name of the list, describe what the data contained in the list represents in your program, and explain how it manages complexity by explaining why your program code could not be written or how it would be written differently if you did not use the list. All right, so back over here. So let's think about the difference between row 2 and row 3. So row 2 is just kind of about the data abstraction. So we need to have the 2 program code segments that do what the written response asked us to. We need to identify the name of the variable that is being used for the list, and we need to describe what the data contained in this list is representing in the program. Row 3 is talking about including a program code segment that shows a list being used to manage complexity and explains how the named selected list manages complexity. So if we look back at that written response, that's all coming from this Roman numeral 5 right here. Everything up to that is all for row 2. This last box right here is 1 full point out of the 6 points for row 3. So I'm not going to go too deep into this, but you can read through kind of this kind of decision rules portion over here. That'll be important when we go on to scoring, but let's keep going. So if we look at row 4 and row 5, notice that these are now about written response 3C. So just to remind you, 3C is where we're now looking at a function. So we need 2 program code segments that you developed. The first program code segment must be a student developed procedure or function. And the second program code segment must show where your function is being called in your program. So you need to show both of those things. And then we need written responses. So let's just see where these points are coming from. Row 4. The written response includes 2 program code segments. So if we have a student developed procedure or function with at least 1 parameter that has an effect on the functionality of the function, and we need 1 program code segment where the function is being called, and if the written response describes what the identified function does and how it contributes to the overall functionality of the program, that's 1 point. The second point, row 5, is coming from a little bit more depth. So this would be further on in 3C. We need a written response that includes a program code segment of a student developed algorithm that includes sequencing, selection, and iteration. So that all needs to be within our function. We need to explain in detailed steps how the identified algorithm works in enough detail that someone else could recreate it. Okay, and so you can read through the rest of this here. Requirements: the algorithm being described can utilize existing language functionality or library calls. An algorithm that contains selection and iteration also contains sequencing automatically. An algorithm containing sequence and selection and iteration that is not contained in a procedure can earn this point. So even if this isn't inside a function, you can still earn row 5. You just wouldn't earn row 4, which is about the function part. Use the first code segment as well as any included code for procedures called within this first code segment to determine whether the point is earned. So if there's a function inside of your function, that could still count here. If this code segment calls other student-developed procedures, the procedures called from within the main procedure can be considered when evaluating whether the elements of sequencing, selection, and iteration are present. So if you have a function inside of a function, but that function somewhere else in the code, that can still be considered part of this. Okay, that's a little bit more detailed than I think we needed to get right now, but hopefully you see where this is coming from. Last step is row 6 for testing. The written response must describe 2 calls to the selected procedure identified in written response 3C. This is talking about response 3D. So let's just briefly look down here and see what this is talking about. We need 2 calls to the procedure from 3C. That's exactly what we said here. We need to describe the conditions being tested by each call and identify the result of each call. That's really talking about all of 3D. So if we are able to complete all of 3D successfully, then we get row 6, or that 6th point from the rubric. Even if we don't earn row 4, we can still get this row for testing. We do not award a point if any one or more of the following is true. Procedure is not identified in written response 3C, or the procedure does not have a parameter. Written response for 3D does not apply to the procedure in 3C. etc. You can read through those yourself, okay? All right, so here's what we're gonna do. I'm gonna show you a sample project that scored a 6 out of 6, and we're gonna talk about why the video and the written responses earned this student a 6 out of 6 from this rubric. Then you're gonna score 2 more samples yourself. So let me just show you the video that goes along with sample 1. And if you've been completing all of our assignments, this app is probably gonna look familiar. And this is a pretty simple app, but it scores a 6 out of 6. It does everything that College Board requires for this project. So take a look at this video. You can see in this video, the student is showing that when they select different numbers or different letters from the dropdown, words appear that have that number of letters that start with the given letter. Right? All right, pretty simple. So that was showing the input, which was what the user picked from the dropdown. It was showing the output and the functionality of the program. So now we're going to switch over to this person's written responses. So this is all that the student was submitting to College Board. You can see there's some code segments that were copy and pasted in here. And I'm going to briefly give you this overview of this, and then we're going to kind of dig deep into why this student earned each of the points. So 3A, we first described the overall purpose of the program. The purpose of the Word Game Helper app is to assist users in finding words to help in various games like Scrabble or crossword puzzles. The video shows how the user selects the length of the word and the first letter from different dropdowns. One sentence, that was enough. Then we have to describe the input and output of the program. The user inputs a value to the program using the dropdowns. The output, which is a list of words that meet the chosen conditions, is displayed on the screen. Okay, that was it for 3A. For 3B then, we need how data is stored in a list. That text was from the program code was screenshotted and put in here. Then the next program segment must show how the data in this same list is being processed. So we recognize this from JavaScript from code.org, right? We're getting column from words, just the word. Then you can see this is how we're filtering that list to get just the number of letters in the word and the starting letter. And the written response is going to explain this. So online, a list is called word list, collects all of the words from the words database and stores them as a list. Each word is stored as a string. The word list is used in the program to show users suggested words of various lengths, starting with a given letter. For example, if the user selects a length of 2 and the letter B, the filter function is called in which the word list is traversed. Each element that is a length of 2 and starts with a B is added to a new filtered list. This list is what is outputted to the user. Great. Then we need to talk about how we can manage complexity and how the program code would be written differently if you did not use a list. The word list manages complexity because it allows any number of words to be stored in the list instead of using individual variables for each word, which would then be checked one by one to see if it met the requirements. The program would extend from 32 lines long to thousands of lines long to account for all of these extra variables. If words are added or removed to the data set this list pulls from, nothing will need to change about the code. The list allows the program to work for any number of words since the filter function will traverse the entire list of words, no matter its length, right? Perfect. 3C is when we capture and paste 2 program code segments for a certain procedure. Remember, we're calling that a function in JavaScript. So we need a program code segment that defines the function's name and return type. We have the name filter. And it doesn't look like this specific function has return. It just sets text instead, which is a valid option of quote, returning something. It is kind of having an output. It's just not specifically what we learned as return. We contain and use one or more parameters. We've got len and letter. And we implement an algorithm that includes sequencing, selection, and iteration. You can see we've got for loop and if statements, so that's going to accomplish that task. Second program code segment must show where the student developed procedure is being called. So you can see we have our function, which is called filter. And then in line 4, apparently, filter is being called. So that's where we called this function. Great. Then we have written responses. I'm not going to specifically read each one of these, but this first response describes in general what the selected procedure does and how it contributes to the functionality of the program. The second response talks about how the algorithm implemented in the selected procedure accomplishes its task, and this explanation must be detailed enough for someone else to recreate it. All right, so this one I really like. Lines 16 and 30 show and hide an image to let the user know the program is working. Once the list has been filtered, the image is hidden. To filter the list, a for loop is used in line 20, which traverses word list. The if statement on line 21 checks to see if the element at the index is the required length, etc. So you can tell the depth of this explanation here is showing that someone else could recreate this if necessary. And I like how they keep referencing line numbers. Those lines are clear up in the code that was copy and pasted above. So it's very clear what's happening. Okay. 3D then talks about 2 calls to the selected procedure. And those calls don't need to be like literally copy and pasted from the program, like in line 4. We're saying like, let's just say that there are 2 different arguments. What could they be? So the first call, let's suppose the user selects from the dropdown the length 3 and the letter D. Another example would be if the function was called with the arguments 1 and B. Okay. By the first call, this would just kind of like go through what happens, and in the second one, we'll see what happens. And then the results. So for the first one, there are, words that actually show up, but there are no words that have a length of 1 and a first letter B. So the results would be that there's nothing found. Okay. So that's 2 different outcomes, which is kind of what our goal is there. All right. So that's all of this person's written responses. As I said, they scored a 6 out of 6. So now I'm going to just go through and show you exactly why they scored each one of those points. And you can see here for row 1, we have a video and response 3A. That's the only things we're allowed to look at, which is over here on the left. So how this is formatted is the student response is in the left. The scoring guidelines are right here. And then if they earned the row, and comments are down here. So the response earned a point for row 1. Response describes the purpose of the app is to assist users in finding words to help in various games. Input and output are shown in the video and described in the response as drop downs and list of words displayed on the screen. So we get the point. Anything highlighted was especially important in the earning of the point. Row 2, we have a point for the row. The program code shows how the list is created and processed in the 2 code segments. The name of the list is identified as word list, and the list stores words that are displayed to the user. Row 3 also has to do with response 3B about complexity. We do earn the points for the row. The response explains that the code would be written differently without the list by storing each word individually in its own variable, which would require extra program code. It also explains that the code allows the program to work for any length word list without any changes. Okay, next up we have row 4, which has to do with 3C. This is specifically talking about the function. The code segment is a procedure or function with parameters, len and letter. The written response explains what the procedure's purpose is in the overall program to output a filtered word list to users which meets their chosen requirements. 3C is about algorithm implementation. The written response explains in detail, line by line, how the algorithm works, which filters a list according to length and the first letter. Remember, we need sequencing, selection, and iteration. Sequencing means we need more than one line inside of the function. So line by line, the program code runs. Selection means we have an if statement, and iteration means we have a for loop. So once we have all those things and we explain all of them, then we're good to go. And lastly, we have row 6, which has to do with the response 3D. The written response clearly explains 2 different calls to the procedure. 2 examples are given with different parameters, which result in different segments of code running. The results of each call are explained. Any word that had a length of 3 and started with the letter D have been added to the filtered list, and no word is found with these conditions, and therefore the filtered list is blank until lines 26 to 28, where a string is added to let the user know that no word was found that met the conditions. Extra commentary. While the student earned the point, we believe a stronger case for the requirement that each call must pass a different argument causing a different segment of code to execute would be made if the code included an if-else or an if-else-if statement. All right, so that's extra, but the student did receive points for row 6. Okay, so that's that. This was an excellent example, right? Because this person got a 6 out of 6. And again, hopefully you see that this project doesn't have to be that scary. This game probably didn't take that long for someone to code. You obviously can't use this example, but it's not bad. So here's the deal. That was a step-by-step walkthrough of somebody's project. There are 2 more samples that you're going to now read and score on your own. On your activity guide, I'm going to provide you with the sample video, the sample written responses. You're going to score, and then you can look at the official rubric that's annotated, just like this one, to see how the person actual scored. And then your job is going to be to compare that with your own scores to see if it matches. All right. So that's the rest of your tasks for this lesson. Thank you so much for watching and have a great day.